2.3.0, adding and subtracting fractions. To add fractions, first find a common denominator and convert them to equivalent fractions. Once the denominators are the same, add the numerators. The following steps show the process for adding 3/4 and 5/8. So first, the fraction's common denominator. One common denominator is 32. The lowest common denominator is 8 because 4 goes into 8 twice. So both choices work fine and give equally valid results. I would say 6/8 plus 5/8 is 11/8. Okay, they're doing 30 seconds. So they said 3 times 8 is 24, and 4 times 8 is 32. 5 times 4 is 20, 8 times 4 is 32. So they're going to add 24 30 seconds plus 20 30 seconds, and they got 44 30 seconds. Now reduce the fraction to its lowest terms. For this example, both the numerator and the denominator are divisible by 4. So we'll divide the numerator by 4, we'll divide the denominator by 4, and it's 11/8. So doing so results in a fraction of 11/8. It's an improper fraction, so we have to subtract 8 from the 11 and get 3/8. So it's 1 3/8. Any common denominator will work, but the lowest common denominator gives the reduced result. Subtracting fractions is like adding them. Begin by finding a common denominator. For example, a painter has 7/8 of a liter of paint. Another worker asks for 1/4 of a liter. How much will be left? Okay. Well, let's do this one. So he has 7/8. And his buddy asks for 1/4 of a liter. So I'm going to go ahead and in my head, I'm going to call this 2/8. I multiplied 1/4 by 2/2. So 7/8 minus 2/8 equals 5/8. Notice the denominator did not change. Do not subtract the denominator from itself. This is 7 pieces of a pizza pie that has been cut into 8 equal pieces. So we have a pizza here, and we've cut that pizza into 8 equal pieces. Let's see if I can do this here. There. So this piece is already gone. Somebody came and they ate 1/8 of this pizza. So there's 7/8. There are 7 pieces of a pizza that had been cut into 8 pieces, and someone else comes and eats 2 more pieces of those 8 pieces. How many, actually, you know what, I'm just going to go ahead and use the original color of black because that'll make more sense. So how many pieces are left when those 3 pieces have been eaten? We have 5/8 left. We have 5 slices of pizza that was originally cut into 8 pieces left over. So 7/8 minus 2/8 equals 5/8. Okay, very good. All right. That's what they're doing here. They're going to multiply the 1/4 by 2/2 to get 2/8. And then they subtract 2/8 subtracted from 7/8 equals 5/8. Okay. 2.3.1 study problems, adding and subtracting fractions. So they want us to add these fractions together And then they want us to subtract these other numbers. So let's do that. So here I have 1/8 plus 4/16. So in my head, I know that 4/16 is actually 1/4 because 4 is divisible by 4 and 16 is divisible by 4. So if you can do that, go ahead and write this as 1/4. Say 1/8 plus 1/4. Well, let's find a common denominator. 4 will go into 8. So we're going to increase this 1/4 to 2/8 by multiplying it by 2 over 2. Remember, anytime you multiply something by 1, you have not changed it. And 2 divided by 2 is 1. So if we multiply 1/4 times 2 over 2, we haven't changed 1/4 at all. It's still 1/4. So 1 times 2 is 2, and 4 times 2 is 8. So 2/8 equals 1/4. So now we have 1/8 plus 2/8 equals 3/8. Notice that I did not add the denominators, only the numerators. Remember, this is 1 piece of pie cut into 8 pieces. This is 2 pieces of pie cut into 8 pieces. That equals 3 pieces of pie. That pie was cut into 8 pieces originally. Okay. All right. 4/8 plus 6/16. Now, I'm going to use their original numbers. I'm not going to change anything in my head. It's good if you can do that, but if you can't, then we'll just use their original numbers here. 6/16. And we'll say 8 goes into 16 twice. So we're going to take 4/8 and we're going to multiply it times 2 over 2. And 4 times 2 equals 8. And 8 times 2 equals 16. So 8/16 is equivalent to 4/8. We haven't changed it, but now we have common denominators. We can write 6/8. I'm sorry, excuse me, 6/16 plus 8/16. And then we can add them together and get 14/16. Okay, 6/16 plus 8/16 equals 14/16. And we can reduce 14/16 by dividing 14 by 2 and dividing 16 by 2. And why do I keep hitting that button? My finger keeps hitting something and I keep changing it. But 14 divided by 2 is 7, and 16 divided by 2 equals 8. So 4/8 plus 6/16 equals 7/8. Okay. We could have actually reduced 6/16 if we had wanted to. If we had wanted to, we can take 6/16 and change it into 3/8 by dividing 6 divided by 2, 6 divided by 2, and 16 divided by 2. So I could get 3/8. And in a case like that, we'd end up with 4/8 plus 3/8. That equals 7/8. Again, you don't add the denominators, you only add the numerators. Okay. The next one is 2/4 plus 3/4. All right. Let's see that. Let's see that in action. 2/4 plus 3/4. They already have a common denominator. So we'll just go ahead and add them together. 2/4 plus 3/4 equals 5/4. This is an improper fraction because the numerator is larger than the denominator. It's top heavy. It's going to roll over. It's going to capsize. So we have to take 4. We have to subtract 4 from 5, leaving 1 over 4. And that 4 that we subtracted is over here as 1. This is 1. It's 4 over 4 plus 1 over 4. So 1 1/4 is the same as 5/4. And here are my 2 pizza pies. I must be hungry, always talking about pizza. So here's 1, 2, 3, 4, 5/4. This is 5 pieces of pizza that was cut into 4 pieces. This is 5/4. 1, 2, 3, 4, 5/4, which equals 1 whole pizza and 1/4 of another pizza. So 5/4 equals 1 1/4. Okay. Uh, 3/4 plus 2/8. There again, I have 3/4 plus 2/8. I'm going to go ahead and reduce 2/8 to 1/4 in my head because I know 2/8, 2 can go into 8 4 times. So if I divide 2/8 by 2 over 2, I'll get 2 divided by 2 is 1, and 8 divided by 2 is 4. Now I have a common denominator, and I can add 3/4 plus 1/4. That gives me 4/4. And you know what that equals? That equals 1. Okay. 3/4. Excuse me. Okay, that was that one. So 4/16 plus 3/8. There again, we have 4/16 plus 3/8. Well, I guess I could double this. I could multiply it times 2 over 2 and get 6 over 16. That's fine. So 4 over 16 plus 6 over 16 equals 10 over 16. And I can divide 10 by 2, which equals 5. And I can divide 16 by 2, which equals 8. Now, if I had wanted to, originally, what I could have done was, let me make a circle around all this and make it go away. I could have said 4/16 plus 3/8. I'm going to reduce 4/16 to 2/8. 4 divided by 2 is 2. And 16 divided by 2 is 8. So it equals 2/8 plus 3/8. And 2/8 plus 3/8. You guessed it, it equals 5/8. That's the same answer as we found a moment ago. It's 5/8. Very good. Now they want us to subtract some fractions. So let's practice subtracting these fractions. 3/8 minus 5/16. And the thing about subtracting fractions is hopefully the first fraction is larger than the second fraction. If the first fraction were smaller, you'd end up with a negative number. I don't think they want us to do that. It's not impossible, but I don't think that they want us to do that just yet. So we have 3/8 minus 5/16. 3/8 minus 5/16. Well, I'm going to increase my 3/8 to 6/16 by multiplying the 3 times 2 and the 8 times 2. 6/16 minus 5/16 equals 1/16. 6/16 minus 5/16 equals 1/16. Okay. 11/16 minus 5/8 equals, well, I'm going to multiply the 5 times 2, and I'm going to multiply the 8 times 2. 5 times 2 is 10, and 8 times 2 is 16, so I have 11/16 minus 10/16 equals 1/16. Very good. I hope that's what you got. 3/4 minus 2/6. So 3/4 minus 2/6. Now this is an interesting one because we're going to have to change them both in order to get a common denominator. 4 goes into 12 and 6 goes into 12. So 3/4 I'm going to multiply times 3 over 3. I'm going to get 3 times 3 is 9, 3 times 4 is 12, minus, now 2/6 I'm going to multiply times 2 over 2. I'm going to get 2 times 2 is 4, and 2 times 6 is 12. So it's equal to our original problem of 3/4 minus 2/6, but it's 9/12 minus 4/12, and it equals 5/12. Subtract the numerators, leave the denominators the same. 11/12 minus 4/8. 11/12 minus 4/8. Okay. So I'm going to have to go to 24. I'm going to have to double 11/12. And I'm going to have to times it by 3, 4/8. So 11 times 2 is 22. And 12 times 2 is 24. Minus 4 times 3 is 12. And 4 times 8, oh, silly me. I'm sorry, 4 times 3 and 3 times 8 is 24. I meant to say 3 times 4 is 12 and 3 times 8 is 24. So I have 22 24ths minus 12 24ths. That equals 10 24ths. So I can reduce this by half by dividing by 5 over 5. I'm sorry, by dividing by 2 over 2. And 10 divided by 2 is 5. And 24 divided by 2 is 12. So I end up with 5/12. 5/12. Okay. 11/16 minus a half. 11/16 minus 1/2. And I'm going to multiply these times 8 to get the common denominator of 16. So I have 11/16 minus 8/16. And that equals 11 minus 8 is 3. And I'll leave the denominators alone. 16. 3/16. Okay. Subtract the following fractions and whole numbers. Reduce the result to the lowest terms and change any improper fractions. 8 minus 3/4. Okay. Okay. I know 3/4 is less than 1. So in order to subtract 3/4 from 8, I'm just going to take one of the ones away from it and make it 7 and 4/4. And that's equal to 1. So 7 and 4/4 is equal to 8 minus 3/4. Now, I'm going to ignore the 7 and just look at the 4/4 minus the 3/4. And I'm going to put 1/4. And then the 7, I'm going to write it over here. So 7 and 4/4 minus 3/4 equals 7 and 1/4. 12 minus 5/8. So again, I'm going to do 11 and 8/8 minus 5/8. I'm going to write down my 11, and 8 minus 5 is 3, and I'm going to leave the denominator the same, 11 and 3/8. 2 punches are made from steel bar stock 9 and 7/16 inches long. If one punch is 4 and a 64th inch long, and the other is 4 and 3/32, how many inches of stock are wasted? Okay, all right, we can do this. I'm going to try to convert all of my numbers to 64. So I'm going to write this problem again, but this time I'm going to say the piece of stock is 9 and 28/64. And I apologize. What I did was I multiplied 7/16. You know what? Okay, let me start over. I don't want to skip any steps. 9 and 7/16. That's how long our piece of stock is. Minus, now I'm going to add these two numbers together. I'm going to add 4 and 1. Shoot, let me get rid of that. I'm going to add 4 and 1/64 plus 4 and 3/32. And then I'm going to subtract that from 9 and 7/16. So 4 and 1/64 plus 4 and 3/32. I'm going to multiply 3/32 by 2/2. And 3 times 2 is 6. And 32 times 2 is 64. So I've changed this to a common denominator. And I have 1/64 plus 6/64. I'm going to add my whole numbers together. 4 plus 4 is 8. And 1 plus 6 is 7. And my denominator will stay as 64. So 8 and 7/64. Now, 9 and 7/16, I have to multiply the 7/16 times 4 over 4 to get a common denominator to be 64. So I have 9 and 7 times 4 is 28, and 16 times 4 is 64. 9 and 28 64ths minus 8 and 7 64ths equals, first I'll subtract the whole number, 9 minus 8 equals 1, and 28 minus 7 equals 21. I'll leave the denominator the same. So 9 and 28 64ths minus 8 and 7 64ths equals 1 and 21 64ths. Okay. All right. I'm going to skip ahead. I'm going to go on from here. (2.4.0) Multiplying and dividing fractions. Multiplying and dividing fractions differs from adding and subtracting fractions. A common denominator is not required. Follow these steps to multiply 4/8 and 5/6. It's actually easier to multiply fractions than it is to add fractions, because like they're showing here, 4/8 times 5/6, just multiply straight across. 4 times 5 equals 20, and 8 times 6 equals 48. It's 20/48. Now, we can divide by 4 and say 20 divided by 4 is 5, and 48 divided by 4 is 12. So we can reduce this to 5/12. If possible, reduce the result to its lowest term. In this example, 20/48 reduces to 5/12, since both the numerator and the denominator are divisible by 4. Fractions do not need to be reduced before multiplying, but reducing them first makes the multiplication easier. So we could simplify at least the 4/8. We could have simplified 4/8. We know 4/8 is 1/2. So we could have said 1/2 times 5/6. Where did I get 5/4? I'm sorry. Okay. 1/2 times 5/6. And that would have been 1 times 5 equals 5, and 2 times 6 equals 12. And that's the answer they ended up with, 5/12. So yes, reduce your fractions before you multiply them. That is a good suggestion. Dividing, we're going to do something called inverting. We're going to flip over the fraction. Dividing fractions is like multiplying fractions, but with one difference. Before multiplying, invert or flip the divisor fraction. To reverse the order or position of numbers in fractions, inverting means reversing the position of the numerator and the denominator. So 3/4 becomes 4/3. When dividing by fractions, one fraction is inverted. The second of the two fractions is inverted. So if you're dividing 1/2 and 3/4, invert the divisor fraction. 3/4 becomes 4/3. Change the division sign to multiplication. So now you end up with 1/2 times 4/3. And 1 times 4 is 4, and 2 times 3 is 6. So our answer comes out to be 4/6, which can be reduced to 2/3. All right, we'll do a couple of examples of that. To divide a fraction by a whole number, convert the whole number to a fraction by putting it over 1. Remember that 4/1 is the same as 4. Okay, let's see here. Let's get study problems. 2.4.1. Let's do the study problems. I think we'll get more out of it that way. Without using a calculator, find the answer to the following multiplication problems. Reduce results to their lowest terms, change any improper fractions to mixed numbers. So we have 4/16 times 5/8. And again, 4/16, I'm going to reduce that to 1/4 times 5/8. And we can see that 16 is divisible by 4, so I'm going to say 4 divided by 4 is 1, and 16 divided by 4 is 4, times 5 over 8, which cannot be reduced any further. So I have 1 times 5 equals 5, and 4 times 8 equals 32. And that's our final answer, 5/32. Number 2 is 3/4 times 7/8. So 3 times 7 equals 21, and 4 times 8 equals 32. Final answer. There you go. There's my final answer for that one. Okay. 2/8 times 15. Well, I'm going to change 2/8 to 1/4 because I know 8 is divisible by 2. So 2 divided by 2 is 1, and 8 divided by 2 is 4, so that's 1/4 times, and I'm going to write 15 as 15 over 1. And 1 times 15 is 15, and 4 times 1 is 4. So 2/8 times 15 equals 15/4. The next one is 3/7 times 49. So I'm going to write it as 49 over 1. Okay. All right. Let's continue on. And I think that there's something we can do called cross canceling. We have 49 on the numerator of one fraction, and we have 7 on the denominator of another fraction. And 49 is 7 times 7. So let's see if I'm mistaken here. I think that we can rewrite this as, let me use a different color ink here. I'm going to change the 49 to a 7. I'm going to change the 7 to a 1. And I'm going to say 3 times 7 equals 21. And 1 times 1 equals 1. So I'm going to say this equals 21. Now let's do it the long way and see if I was right. 3 times 7, I'm sorry, 3 over 7 times 49 over 1. So 7 times 1 is 7. And here 3 times 49 is 148. Is that correct? I think it is. I'm sorry, 147. What did I say? Let me get this out of here. 147 there. So 9 times 3 is 27. 3 times 4 is 12, and 2 is 14, so 147. And I believe that 147 is divisible by 7. 7 goes into 14 twice. That equals 14. Bring down the 7. 7 goes to 7 once, evenly. So it equals 0. So my answer is 21. Yes, very good. We did something called cross-canceling, where if you have a multiplication problem, you can take the denominator of one fraction and the numerator of another fraction. And if they are divisible by each other, you can reduce them both. And it's a quick way of finding the lowest form of an answer. Okay. Without using a calculator, find the answer to the following division problems. 3/8 divided by 3. All right. So here we have 3/8 divided by 3. And I'm going to write 3 as 3 over 1. And because of that, I'm going to say 3/8 times 1 over 3. I'm going to invert the dividend, and I'm going to change my symbol from divide to times. And I could also cross cancel because I have 2 3's. So I can make this a 1, make this a 1. I could say 1 times 1 is 1, and 8 times 1 is 8. So if I have 3/8 and I say, what is 1/3? If I'm going to divide this by 3, then I'm going to end up with 1/8. So we end up with 1/8 plus 1/8 plus 1/8 equals 3/8. So that tells us that 1/8 is 1/3 of 3/8. So very good, we found that. Okay. Here, 5/8 divided by 1/2. So we have 5 over 8 times 2 over 1. There again, we're going to invert and multiply. Invert the 1/2 and change your sign to multiplication. Now we'll cross cancel by changing the 2 to a 1, change the 8 to a 4. 5 times 1 is 5, and 4 times 1 is 4. So we ended up with 5/4, which means we're going to subtract 4 from the 5 and make it 1/4, and that was one whole number, 1 1/4. So 5/8 divided by 1/2 is 1 1/4. And here, 3/4 divided by 3/8. 3 over 4 divided by 3/8. I'm going to say times 8 over 3. I'm going to change my symbol to multiplication, and I'm going to invert the dividend. So now I can cross cancel. I can say 4 goes into 8 twice, so this 4 is a 1 and this 8 is a 2. And these 2 3's can cancel, becoming a 1 and a 1. So 1 times 2 is 2, and 1 times 1 is 1. So my answer is 2. So, and in fact, we can kind of see that 3/4 divided by 3/8 is 2. You could put 3/8 into 3/4 twice. Okay. Let's see. I'm going to move ahead, I think. Yeah, let's move ahead. Section 2 review. Which of the following fraction pairs are equivalent fractions? 1/2 and 17/32. No, 16/32 would be 1/2. 1/2 and 32/64. Yes. 1/2 and 3/4. No. 1/2 and 63 1/28. No. It's very close. 63 1/26. So B is the only pair of equivalent fractions. The improper fraction 76/64 converts to the mixed number 1 and 9/32. Well, let's see. If we took 64 from 76, let's do this here. We have 76 over 64. So 76 minus 64 is 12/64. So this equals 1 and 12/64. but 12 is divisible by 4, and 64 is divisible by 64 by 4. So this equals 16, and 12 divided by 4 is 3. So 1 and 3/16. So they said 1 and 9/32, so the answer is false. False. 11/16 plus 3/8. 11/16 plus 3/8. Well, I'm going to change 3/8 to 6/16 just to make it easy on myself. Equals 17/16, which means I have to make it a mixed number 1 and 1/16. If I subtracted 16 from 17, it would only be 1/16, and then I have a whole number 1. It says 1 1/4 minus 7/16 equals what? So I'm going to do a little magic here. I'm going to say 1 1/4 minus 7/16. I'm going to change this to an improper fraction. 5/4 minus 7/16. And then I'm going to multiply 5/4 times 4 over 4. And I'm going to get 20/16 minus 7/16. And that will equal 13/16. There we go. D, 13/16. And we have 1/8 times 1/10, which is 1/80th. 1 times 1 is 1, and 8 times 10 is 80, so it's 1/80th. And last but not least, 7/16 divided by 7/8. 7/16 divided by 7/8. I'm going to say times 8/7. I'm going to invert and multiply. And I'm going to cross cancel. 8 becomes 1 and 16 becomes 2. And 7 becomes 1 and 7 becomes 1. So 1 times 1 is 1, and 2 times 1 is 2. So 7/16 divided by 7/8 equals 1/2.